Okay, so the unit 4, number 14 from the free response, it gives you this graph, and it's kind of a trapezoid that repeats itself here. So the graph of the function is made up of these 6 line segments, and they're telling us that g of x is the integral from 0 to x of f of t dt. So right here I make myself a note that that is the area under the curve, okay, or between the curve and the x-axis, okay? So between the curve and x-axis, so I make myself that note. And now in part A, they're asking me to find g of 4. Okay, so to find g of 4, I'm going to take this 4 and I'm going to plug it in wherever I see an x. So for part A, g of 4, that means it's going to be the integral from 0 to 4, okay, of f of t dt. So that means I need to find the area under this curve from 0 to 4. So I'm going to use kind of an alternate color here. So I'm going to kind of break that area up into 2 pieces. So first I'll figure out the area from 0 to 1. So that would be this triangle right there. It's below, so that's going to be a negative. So the area of this triangle is going to be base is 1. The height is 2. So base times height is 2. But divided by 2, right? Because the area of a triangle is base times height divided by 2. So that gives me a 1 again. But it's below, so it's going to be that little piece is, I'm just going to label it a negative 1. And then if I had to figure out the area of this trapezoid, if you don't remember your trapezoid formula where you have to add up the bases, multiply by the height, then divide by 2, that's fine. You could always break it up into 2 triangles and the rectangle. So again, here's a triangle. Its base is 1. Height is 2, but you divide by 2, so that's going to be a positive 1 there. Similarly, it's going to be a positive 1 for that triangle. And then the area of this rectangle, base is 1, height is 2, so this is 2. Or if you just calculated the area of the trapezoid, you would get 4. Okay? All right, so when you are, that was kind of my scratch work, but if this was the AP exam, I would definitely want to show that. So I'm saying that it's going to be negative 1/2 my base times height. That's for that first piece. Plus, and then you can do each triangle separately. I think most of my students would probably break that trapezoid up into those triangles, so that's what I'm going to do. And again, that's going to be base times height. It's positive this time because this piece is above the x-axis. And then we're going to have the area of a rectangle is base times height. And then the area of that last triangle up here is going to be 1/2 base times height. So that's my work. And we kind of already figured out that this was a negative 1 plus 1 plus 2 plus 1. So that gives me a total of 3. And so if you would have gotten that, I think you got 1 point on the scoring guide for that. So that's definitely an easy point that I would want you to get on the AP exam. And still in part A, so I'm still in part A, but now I'm going to try to find g prime of 4. Okay, so if I'm trying to find g prime, that means I'm taking the derivative of this. Well, what happens there? Okay, so if you were kind of writing it, I'd say this, and it'll be the derivative like that, dt. And what happens when you take the integral of the derivative? Well, then your second fundamental theorem of calculus applies there. I can kind of scooch that because I don't need the picture right now. So your second fundamental theorem of calculus applies, and we can say, well, you're going to take this x and replace that t with the x. Notice here your fundamental theorem, your second fundamental theorem of calculus applies because you're going from 0 to or from a number to x. In this case, it's 0 to x. I don't need to do anything special because the order is correct, and this is going to an x, not an x squared or anything. So you're good there. So what's going to happen then is this is going to be f of x, which is basically going to be f of 4. Okay, because when you integrate there, you're going to replace it, and the integral kills off the derivative. So we're going to get this, and f of 4. How do you figure out what f of 4 is? You got to go back up to your drawing here, because this is the graph of f. So f of 4 equals 0. So then you could fill that in. So you've got that. And then the last part for part A was the second derivative at 4. So now we have to look at this graph. We want to figure out the second derivative. So the second derivative, if this is already like the first derivative, then to look at the second one, we have to analyze the slope at 4. So to figure out the slope at 4, you're just going to have to use your 2 points. And if you have 2 points, you calculate the slope by doing y2 minus y1 over x2 minus x1. So here, just know that this equals, I'm going to kind of write that out. So it's the slope of the given graph. Okay? So I'm going to say that we're going to do 2 and then minus a negative 2, right? And then, because I'm using the point this and this, so this was my x1, y1, x2, y2. It doesn't matter the order, but I did it this way. And that's 3 minus 5. So that's going to give you 4 over negative 2, which is negative 2. Oh, sorry, this is supposed to be a plus 2 there. Okay? So again, I just use, and you can use the points in either order, but I was trying to find the slope at 4, so I used this point and that point to calculate my slope. And if you got all those right, you would have gotten 3 points for your AP exam. So then we'll go on to part B. Okay, in part B, it says, does it have a relative max, min, or neither at x equals 1? So part of the challenge here is that you have to figure out what you're looking at. What you need to realize here is that max and mins occur for g when the derivative, right, is 0. Well, the derivative of g, going back to up here, the derivative of this is actually this graph. So critical values occur when the derivative equals 0. So there'd be a critical value at negative 4, negative 1, 1, and 4. Okay? Once you know that, you're like, okay, 1 is a critical value, and it's asking me at 1, is it a relative max or min? So if at negative 1 it was negative and then it goes to positive, you could almost think of it like on a sign chart. If your sign chart went from negative to positive, that means that the original was decreasing and then increasing. So that would mean that at 1, you had a relative minimum. Remember, a sign chart is not enough to get you credit. Okay, so you need to have some sort of explanation. So I would say relative min slash maxes, okay, occur at critical values. Okay, and for this, we're going to have my g prime, okay, is equal to f of x, right? So we want to know where that changes positivity. So there's going to be zeros. Look for changes in positivity. Okay, and then it goes there. So at x equals 1, you go from, the graph goes from positive, or from negative to positive. From negative to positive, and therefore it is a relative minimum. Okay, so we've got that. Okay, in part C, they're kind of giving you some information. So let's take a look at what they're actually telling you. So it says, suppose that it's defined for real numbers and it's periodic with a length of 5. Okay, so they tell us that. The graph shows 2 periods. So basically what that's saying is that periodic functions repeat, and it's saying that its period length is 5. So over any 5 units, the graph will have the exact same picture. And we see that. So you're like, all right, from negative 5 to 0, and then from 0 to 5, you know, they're the same, they're symmetrical. Okay, so that makes sense. The graph shows, okay, now it's telling you, it says given that g of 5 equals 2, so that's them telling you this information. It says find g of 10 and write an equation for the line tangent to the graph of g at, 108. Okay, so because they told you that, well, what I need to look at is what is g of 0? Because if I already know g of 5, then I need to figure out, you know, if its length is 5, I need to figure out how it went before. So g of 0, think back to up here. If you plugged a 0 in there, it'd be the integral, right? Because g of 0, so that'd be 0 to 0. Well, 0 to 0, that's applying one of those integral properties. The area under no space is 0. So now I've got that g of 0 equals 0. So what is that actually telling me? If you combine that with the fact that g of 5 equals 2, this tells me that for every 5 units of x that I move, I gain 2 units, okay? So the function increases by 2 for every 5 in x. That's what that's saying. For every 5 of x, you gain, the function gains 2, okay? So that's what I'm kind of writing there. Okay, so basically, they're asking me about g of 10, right? So g of 10 is going to be, well, that means I went into, 5. If it repeats itself every 5 times, that means there was 2 of them. So it's going to be 2 times g of 5, which we already said was 2. So 2 times 2 equals 4. Okay, so that answers the first part of the question. And now it's saying, so write the equation for so find g of 10, check. So that would give me a point out of the 4 for part C. Now it says write the equation of the tangent line to the graph at 108. Well, the first thing you need to realize is that 108, okay, so the integration, so g of 108 is going to be the integration from 0 to 108. Well, 108 is not divisible by 5, and we already said that this 5 is important. So what I'm going to do is I'm going to break it up, and I'm going to say, okay, g of 108, using that second integral property, I can break it up. The integral is like the sum of the two smaller. So I'm going to go from 0 to 105. Why 105? Because I know that 105 is divisible by 5. And that'll be of f of t dt. And then, though, I have to remember I'm still going to get that other part, though. So then I need to go from 105 to 108 of f of t dt. Okay, so how do I figure this part out? Well, just like up here, it was 2 times g of 5. Well, now it's really going to be how many repeats of 5 would I have if I went all the way to 105? So 105 divided by 5 gives me 21. So it's going to be 21 times g of 5, which again, I already know is 2. Okay, so 21 times g of 5 is going to be that. So this part gives me a 42 plus, now I need to figure out this part. Okay, so what would the area be there? Well, if it repeated, it's going to start at the beginning, and I'm only going 3 units. So you almost have to go back up here and say, all right, well, 105, it means it's going to start going over again. So if I had to go 3 units, that means I'm only going to be looking at like this part of it. Well, we know this -1 and that one are going to kill each other off. So then I'm just going to have a 2. So if I had 3 more, an x value of 3, that means I'm going to be at 2 for the area. So that means this part is going to be 2. So 42 plus 2, okay? 42 plus 2 equals 44. So we get to that part. All right, I'm going to have to write out my answer, and then I'll try to explain it because I only have a minute left. Okay, so what that tells me basically is that since I got that 44, that 44 is going to be my y1, and that was with an x value of 108. So this now is a point that I can use. Remember, my goal here is to be able to write the equation of a tangent line. So your goal, whenever you write the equation of the tangent line, you need to be thinking, I need to use that point slope formula. So I've got the point, so far so good, but you need the m. Well, m is the slope, aka the derivative. So you need to take the derivative and then plug in an x value to evaluate the derivative there. But what you need to realize in this graph is that the derivative g prime of 108, again, going back to that fundamental theorem there, well, g prime is equal to f of 108. And then you need to go back and say, okay, well, at 108, okay, at 108, we know that this graph is going to keep repeating itself. So 108 is really going to be almost like coterminal. It's going to be equivalent to 3. And again, because it's that 105, remember we had 3 left over to go from 105 to 108. There was 3 left over. So at x equals 3, the output was a 2 right there. So that is where I got my slope. So once you have that the slope is 2, then you're going to go back and plug in. So y minus y1 equals m parentheses x minus x1, and that is how you get your answer on this one. Hopefully you were able to get, close to the 9 points for this problem.